Hi everyone. Here in this video I'm going to explain to you a very short topic, and that topic is the perfect codes. Okay, because now this is actually the right time to tell you what the perfect codes is, since we have, for looking at the previous videos, we know various definitions, we know what is a syndrome, we also know how many syndromes are there for an NK linear block code. So now we can understand what is a perfect code is. Okay, so we know that for an NK linear block code, there are 2 raised to n minus k syndromes, right? 2 raised to k n minus k syndromes, including the all zero syndrome. And all zero syndrome means a syndrome which does not have any error. The syndrome is equal to 0 means the received vector is equal to the transmitted vector, or the received code word is equal to the transmitted code word, right? That is, R is equal to V. That is the meaning of the sentence. That is, therefore there are 2 raised to n minus k syndromes. So if you take a 6-3 block code, here 6 minus 3 is equal to 3. So therefore there will be 2 raised to 3, which is equal to 8. So there will be 8 syndromes. Like if you, for example, if you take 15,7, okay, if you take 15,7, then the 15 minus 7 is equal to 8. So there will be 2 raised to 8 syndromes, okay, including the all zero syndrome. Now, if only one bit is in error, okay, if you have an error pattern in which only one, if you have a code word in which only one bit is in error, then the possible number of error patterns due to this error is NC1. See, let's take an example. Let's say for a 6-3 code, okay, for a 6-3 code, I'm going to name the code as, I'm going to name the pattern. I don't know how to say the pattern. I'll say the pattern. So I'm going to name the pattern as E1, E2, E3, E4, E5, E6. Okay, so if one of them is in error, that corresponding bit will be equal to 1. Right? Only if one of them is an error, if only one bit is an error, then one of these values will become 1. So how many possible number of patterns are there in which only one of them will become 1? That value is 6C1. Alright, 6C1, where this is nothing but equal to 6 factorial by 1 factorial into 5 factorial, which is equal to 6. You see, this is how the calculation comes. So therefore there are 6 error patterns that satisfies this sentence. That is, there are 6 error patterns in which only one error in this pattern can take place. Only if one bit is 1. Okay. Now, if only 2 bits are in error, then the possible number of error patterns due to these errors are NC2. Same explanation. That is, I'm taking E1, E2, E3, E4, E5, E6. So what is the possibility that only 2 of them will become 1 and the rest of them are 0? Only 2 of them are in error and the rest of them are not in error. What are the possible chances? What are the possible patterns for that? It will be 6C2. Okay, that's why it's called as NC2, where n is nothing but the number of the output bits or number of the transmitted code words, right? So NC2. In the same way, we all know that the letter T, we all know that T is the total number of errors that the receiver could correct, right? Or T is called as the error correcting capability, right? So if T is the maximum limit to the number of error bits that can be corrected, and also the number of error patterns due to the T error is given by NC2, right? That is the maximum number of error. If one bit is an error, it can be any one of these bits. So therefore there can be 6C1. Now, if it is a 2-bit, then any one of these 2 will be in error. So it will be 6C2. And likewise, for T errors, where T is the maximum number of errors that can be corrected. That means it can be 1 or 2 or 3 or 4. The value of T is an integer. So T is the maximum of errors that can be corrected. So therefore, the number of error patterns, if T is the number of bits that's being wronged, then the number of error patterns will be NCT, just like here. Just like NC1, NC2, here also the number of error patterns will be NCT. So therefore, okay, the total number of all possible correctable error patterns That is, if an error has occurred, and even though if an error has occurred, the receiver will be able to correct that error, will be able to correct the error by itself. Okay, that is, that number, if it is a 1 bit, the receiver can correct it. If it is 2 bit also, the receiver can correct it by itself. And up to how many errors can the receiver correct it? The receiver can correct up to T errors. That is why T is called as the error correcting capability. So totally how many error patterns can the receiver correct it? It will be NC0. NC0 means no error, okay? But that is also included over here. Okay, NC0, because here even though it's not correct, the receiver has, it's already correct, it's considered as a correct version. That's why we consider NC0 also. Okay, so NC0 plus, if the total number of error patterns, if only 1 bit is wrong, the total number of error patterns if only 2 bit is wrong, the total number of error patterns if only 3 bits are wrong. Likewise, total number of error patterns where only T bits are wrong, and T is the maximum number. Any errors greater than T, the receiver will not be able to correct. So this is the total number of error patterns. This is also equal to sigma j is equal to 0 to T NCJ. Okay. Now this is the common property in an NK linear block code. If an NK linear block code is to be capable of correcting up to T errors, then the total number of syndromes, like I said over here, the total number of syndromes will not be less than the total number of all possible correctable error patterns. Or in other words, 2 raised to n minus k, where 2 raised to n minus k is the total number of syndromes, is greater than or equal to the total number of the correctable error patterns. That is sigma j is equal to 0 to T NCJ. This is the one of the important property in NK linear block code. Okay, so what is a perfect code? A perfect code is in which when this equation, right, that you see here, when this equation becomes equal to, that is, if the total number of syndromes is equal to the total number of all the possible correctable error patterns, then that code, that NK linear block code, is called as a perfect code. That is the definition of a perfect code. Okay, the above equation is called the Hamming bound. This equation, okay, this equation right here is called as the Hamming bound. NK linear block code in which the Hamming bound becomes equality, in which the NK linear block in which this equation becomes equality, equal to, then that code is called as the perfect code. A perfect code is the NK linear block code whose total number of syndromes is equal to the total number of all possible correctable error patterns. Or in other words, for a perfect code, 2 raised to n minus k, that is the total number of syndromes, is equal to sigma j is equal to 0 to T NCJ, which is the total number of all possible correctable error patterns. Okay. I will be giving you an example of a perfect code in the next video. Okay, when I'm going to discuss the next topic. The next topic we are going to discuss is the standard array. Okay.